Probability of compound events. For the probability of compound events, first, decide if the two events are independent or dependent. When the outcome of one event does not affect the outcome of another event, the two events are independent. And you're going to use the formula, the probability of A and B is the probability of A times the probability of B. This shows the cards included in a standard 52 card deck. We're going to use this for reference when determining the probabilities related to drawing specific cards or groups of cards. Select a card from a deck of cards, then replace it in the deck, shuffle the deck, and select a second card. What is the probability that you will pick a 6 and then a king? So we're going to multiply the probability of picking a 6 times the probability of picking a king. As you can see here, there's 4 6s in a deck of 52 cards. So the odds of picking a 6 are 4 out of 52. Then a king. So because we replaced the card back, there's still 52 cards in the deck. So this denominator is still 52. And there are 4 possible kings. Therefore, we're going to have 4 over 52 times 4 over 52, giving us a probability of 1 over 169. When the outcome of one event affects the outcome of another event, the two events are dependent. And you're going to use the formula, the probability of A times the probability of B given A. Let's see this in action. Select a card from a deck of cards. Do not replace it in the deck. Do not replace. Then shuffle the deck and select a second card. What is the probability that you will pick a 6 and then a king? As you can see, there's one less card in the deck when you go to choose the second card. So the probability will be different. Alright, so the probability of picking a 6 and then a king is the probability of picking a 6, which is still 4 out of 52. Then the probability of picking a king, now that we're missing a 6 from the deck, is 4 over 51. The denominator went down by 1. Why? After you took out the 6 initially, the total number of cards is reduced by 1. But it wasn't a king initially, so if you had chosen a king and then another king, the numerator would also go down by 1, right? Because there would be one less king to choose from. But in this case, we're removing a 6, which did not affect the number of kings in the deck, but it did affect the total number of cards. Try to name some other independent and dependent events. Here are some independent events: flipping a coin multiple times, flipping a coin and rolling a die, spinning a spinner multiple times, drawing multiple cards from a deck and returning them into the deck after you draw them. Here are some dependent events: drawing multiple cards from a deck and not putting them back into the deck before picking the next cards. Picking 2 marbles from a bag without putting either marble back in before you take more marbles out. Or choosing 2 different students from a class to participate in an event, for example.